Thank you, Christy. Okay. We'll start over again, but I'll say that we've added three new kinds of values to Jedi: text, closure, and then a variable. And the main application of text, func, and variable. Okay, so a thunk here we see is a closure, but it has no parameters. The text is just an expression wrapped up as a value, pretending like it's a value, masquerading as a value. And the issue here is when it's time to execute this expression, what environment do we use? Since the text has no environment, we will use the whatever the environment, the current environment is, which could change the meaning of some of the variables inside of the expression, some of the names, the identifiers. The closure keeps its environment with it. And so when we thought out, at least we have this environment where it was created to use. And the main application of that you should know is this. So we're adding these three parameter passing mechanisms to Jedi. Pass by value, pass by name, and pass by text. I'd like you to know these parameter passing mechanisms. They used to come up routinely at job interview questions and things like that. So we know that in, let's see, just think about where this code was. I'm going to just take a moment here. I just came from a department meeting, so I'm kind of late in getting things set up. So pass by value, that's what Jedi is using now. Pass by value is another word for eager execution. So remember in your fun call.execute, first thing you do is you execute all of the operands and turn them into values. If pass by name is enabled, then the way you convert your operands into values is that you freeze them into thunks. And if pass by text is being used, then you basically delay them into texts. We also have to monkey around with the identifier in order identifier execute. Let's see if this code is up here. Right, so here we are. This is my fun call, execute, and here are my operands. That's a list of expressions, and I'm defining my args. I look in my parameter passing mechanism flag. If it's by name, then I'm going to convert all of my operands into thunks. If it's by text, I convert them all into texts. If it's by value, I just execute them, or whatever kind of value they turn out to be. We also have to fool around a little bit with executing an identifier. So this is the identifier class. Right, and here, when we look something up in the environment, if that thing is a thunk, then it has to be thought out. And we can just call it like a function. That's the apply method. If it's a text, we thaw it out using text apply method. Otherwise, don't do anything. Okay, so that gives you, so is text supposed to take an environment? No. This is a question from Samija. No, that's the point, is that that's the failing of text, is they don't take an environment, right? So when it's time to execute the expression inside of a text, you just have to use whatever the current environment is, which, like I said, is possibly redefine some of the identifiers to be something weird. You know, one of the examples here, let's see, well, we could just see an example. Yeah, I think this is a good example. Right? We define X to be 5. Okay, that's in the global environment. Promise 1 is we're going to freeze 2 times X. We're going to take 2 times X and turn it into a thunk. But we do that in this temporary environment. By temporary, I mean, you know, pseudo-temporary, in which X is 10. So when we say what's promise 1 and identifier.execute thaws it out, we get 2 times 10 is 20. But look here, same thing with promise 2. We delay it, we turn it into a text in an environment where X was 10. Okay, but then when we thaw it out, we don't get 2 times 10, we get 2 times 5. It's because in the environment where we're thawing it out here, this is the global environment where X is 5. And that is sort of upsetting, right? I mean, if you wrote 2 times X, if you were the programmer that wrote this piece of code, you would think I'm multiplying 2 times 10. But no, you're not. You're multiplying 2 times whatever X is at the time that you thaw it out. Anyway, so pass by name, so using thunks is the right way to go. Texts, pass by text, this is something used by like the macro, the preprocessor in C. You know, people get into this kind of problem all of the time with macros in C. These are like, you know, this is like a way of writing functions that get executed by the compiler, not by the computer. And it's like a way of introducing little shorthand pieces of code in C. And they use pass by text there, and it creates all kinds of problems. Anyway, so yeah. Oh yeah, okay. So Samija's raising a good point here on the chat. I had assigned, I assigned this, or I didn't assign, and part of the project was to have a static scope flag, which is set to true. If it's set to false, then dynamic scope is used, right? And so you don't have to do that. I'm not asking you to do that for this assignment, although I probably should. But in order to enable dynamic scoping, we have to pass the environment in to, let's take a look at that, in fact, real quickly. Very observant, Samija. Let's see, Jedi. Let's look at my closure class here. So this is where this turned up. Let's look at fun. Maybe I want to look at fun call first. So here is fun call executes. And when fun call executes, fun call executes, we do f.apply of args, but we add here an extra parameter. We pass in the calling environment. And we have to do that. We have to do that here for thunks as well. Okay, so and then in closure, right, here we're creating our temporary environment. And if static scope is being used, then the temporary environment extends the defining environment. Otherwise, it extends the calling environment, where calling environment is the environment that we passed in. So it's because of this static scope thing, using dynamic scope, or the possibility of dynamic scope, that I had to add this extra env parameter to applying closures and applying funcs. You won't need that though, and you won't need that, I don't think, in your implementation. So then we moved on to Jedi 3. Jedi 3 adds a new kind of, so we got an environment diagram here. A new kind of value. Oops, let's see. A new kind of a value called a variable. The thing about a variable is, you see this has a arrow association content. Variable has a value inside of it. Okay? And that value could be another variable. That value could be a literal value, like an integer, or a real. Could be, a chars, a Boolean, closure, anything at all could go inside of a variable. And so then here we see how it gets used. So I'm defining count to be a variable containing 0. Then when I ask what is count, it prints out 0, but with these weird braces around it. So count isn't 0, it's the variable containing 0. And that's an important distinction I want you to make. If you want to know what's inside of count, then you have to put these same weird braces around count. And it tells you what's inside. In programming languages, this is called dereferencing a variable. And in most programming languages, dereferencing happens automatically unless the variable appears on the left-hand side of the assignment. But here, in our language, we're trying to enforce good habits on our programmers, a clear understanding for our programmers. And so we say, look, did you want the variable count or did you want the content of the variable? You have to make clear by using these brackets. The colon equals here, this is the assignment operator. Okay, this will be a new kind of an expression. Okay, the left-hand side is going to be a variable. The right-hand side can be any expression. And what it does is it takes the value of this expression, it executes the expression, gets some sort of a value, and it stores it. It changes the content of the variable. The variable doesn't change, but the content does. Okay, so here, the value of this expression is 0 plus 1. So the value of this expression is 1. And now when I ask what count is, it's a variable, but now 1 is inside of it. Here's another example. I said, hey, what's count plus 1? And boom, I get an error message. You can't add to variables. Variables aren't numbers. And in this example, p count is a variable containing count. So then when I ask what p count is, look, it's a variable containing 0. And I have to double dereference p count in order to get the 0 out. Okay, and I think, let me just draw this picture once again. Excuse me for 1 minute, I have to moisten my eraser. This little whiteboard that my daughter lent me. then right here. So just to remind you of the environment diagram for variables. You might put it on speaker view. Maybe it would make this picture a little bit bigger. Already doing that. So here is the global environment. Here's count, and it is reference to a box. So that's the variable, and the content is 1. P count is a variable, and its content is a pointer to count's variable. And now if I do this, so now I'm going to do, see at the bottom of the screen, count colon equals 5. Okay, so what happens here, and this is, everybody gets this wrong, it does not change the binding. Remember, a binding is a row in the environment. So count still refers to the exact same box over here, but what's inside the box got changed to 5. So you can think about it this way. The identity, it's the same, in object-oriented programming, we're always talking about the difference between identity and state, right? Like values, identity and state are the same thing. Like a point, a two-dimensional point with X and Y coordinate. Its state are the X and Y coordinates, but if you change one of those coordinates, like you change the X coordinate from 2 to 3, you change the identity of the point. It's now a whole different point. On the other hand, like a bank account, the balance of a bank account, the identity is, it's a bank account, and the state is its current balance. You can change the balance, but it's still the same bank account. In order to enable that idea, those are sometimes called references or entities. And of course, the world is filled with entities. If you get a haircut, you've changed your state, but you're still the same person, right? And so in order to model stuff like that, we need variables. Variables are the ultimate thing that their identity doesn't change, even though their state, their content can change. So that's kind of the beginning of all of that. Stores. So this is just like I decided that I needed some kind of a collection class, like a list or an array or a set or something like that. So a store is like a variable on steroids, right? You can store not just a single value in there, but multiple values. So here I created this store expression, and you can give it just any number of things you want as an input, right? And now it contains, and you can add and remove stuff from a store. But I've taken this out of Jedi 3, so we're not doing stores. Okay, so now we're kind of caught up. Let's move on to the next Jedi feature, which is iteration. Here's what that looks like. While, it's a while loop. And then here is this condition. While the content of count is less than 10, I'm going to execute this block. Okay, I'm going to generate the side effect of calling inc count, and then I'm going to increment count by 1. And here you see these side effects each time we went through this loop, so that proves that the loop is running. And then it just returns done. Done here is the done notification is the return value of Y. Just like done, I think was the return value of assignment. Let me double check that. Yeah, so here we see that if you do an assignment, done is the return value. And so now when I say what's in count, we see that it's now 10. So here is a great sort of final exam kind of question. Give an iterative implementation of the triangle function in Jedi. Now, here, I'm going to show you the formatted version of this. So I'm defining a triangle function. What is a triangle function? That just adds all of the numbers from 0 to n. Okay, so I'm going to, inside this block, here we begin the block, and inside the block, just ignore these underlines, I define result, which is a variable containing 0. I define count, a variable containing 0. And then while count is less than, I would like to say less than or equal to n, but I don't have less than or equal, so I'm going to have less than n plus 1. Result, I'm assigning to results the old result plus the count. I'm going to assign to the count the old count plus 1. And then I have to return the content of result. So up here we see triangle of 5 is 15, triangle of 6 is 21. So it's just the traditional iterative definition. You're adding up all the numbers from 0 to n, but you know, we have to do it in Jedi. Now, unfortunately, you can't put this definition in a file and load it in. You can't even type this definition into Jedi because my Jedi parser is a little bit dumb about this. As soon as it sees an end of line, it starts parsing, right? So the real way that you'd have to enter this is what I've done up here, totally unformatted, just all in a single line of code. So I haven't quite figured out, you know, how to allow multi-line expressions in Jedi yet. Okay, so variables, assignments, operations, and while. So variables are new value, while and assign are new expressions. And of course, dereferencing. Here's the design. Again, we can ignore store. Variable is a value and it has a value. Over here, there is iteration and assignment. They are both special forms. And iteration has the condition, part that goes into the parentheses, and then the body, the part that gets iterated. Assignment has an identifier, the name of the variable, and it has the expression that we're going to update the variable with. Here are some new extensions to the grammar. An assignment, it's a little bit bigger for you. Assignment is an identifier followed by colon equals followed by an expression. Iteration is while followed by a left paren. Here's an expression, that'll be the condition. Right paren, and then followed by, this will be the body, the expression to be iterated. And dereference is an expression enclosed by square braces. Okay. So one thing that you might notice is missing here is var. If we come back up here, right? What about this var guy? What do we have to do there? Well, var is a function call. Okay, so you can treat var, we can make a new ALU function called var. Okay, and var expects one input, not two, not 0, not 50, but one input, otherwise it gets mad, throws an exception. And it takes whatever that input is and it creates a variable with that input as its content, and it returns the variable. So it's a real easy addition to the ALU. So if you put that function in the ALU, a new function called var, and you have to adjust ALU executes, it says, oh, well, if it's var, if the opcode is var, then call this variable function. Then you don't have to like add any additional parser support for var. It's just treated like an ALU function. So let's take a look at some of these files. Let's see, here's alu.scala. These store ops you don't need. Oh, here. So we're going to add a dereference function, and I'm going to call it makeVar. Why do I call it makeVar and not var? Well, because this is Scala code we're looking at, and if you write var in Scala, it thinks you're declaring a variable, all right, because var is reserved by Scala. So, and then here's my dereference function. Okay, and here is, so listen up, here's how it goes. First of all, args should be a list consisting of one value, and that value better be an instance of variable. And if it's not, you throw an exception. If it is, you return the content of that variable. So arg.content. Here's makeVar. Okay. Here's how it works. Args should be a list consisting of exactly one value. Otherwise, you'll get mad, throw an exception. And here you return a new variable. Remember, variable is now going to be a new value class containing args sub 0. New variable arg sub 0. Done. Store ops, no, we don't need any of this stuff, so we can get rid of all of this junk here. We don't need that. Let's look at the parsers. So this is going to extend Jedi 2 parsers. And you need these 3 new parsers: assignment, iteration, dereference. Okay? And then you'll need to override the expression parser. So we're going to put iteration in there. We also add thunk and next. Yes, all of that goes. So Samij is asking about thunk and text, freeze and delay. All of that it goes in there too. Yeah, that's all part of 2.1. So you've got all of the features of 2.0, 2.1, and 3.0. I also override the term parser. So I can put dereference in here, an assignment. So all of that works. So you just have to figure out what to do here. For dereference, okay, here, what you're going to do is make a fun call. You're going to be calling the dereference function in the ALU. For assignment, you're going to be making an assignment expression. Remember, that's a new class. And for iteration, you'll be making an iteration expression. That's also a new class of expression. Console, I don't think there's anything new here. This was the part last year where I tried, where I added this file, reading a file. So you already have that. So you can ignore this code, but don't do what I did here. Remember, don't forget to put in Jedi 3 parsers here. And then here we see a test file that you can run. I did manage to allow you to put in blank lines. So blank lines are okay with my parser. But again, here's that triangle function again. All that has to go on a single line without any carriage returns in it. And then the results, you can sort of see what the results are expected here. Okay. So that summarizes what is due Tuesday night. That's right. So again, Samij is asking, we have to overwrite term there. I didn't have that, did I? Yes, I see. Okay, I understand what Samij is asking. Yeah, let me see if I can fix that for you. So Jedi 2. In fact, I think I have a couple of mistakes in here. Let's look at the Jedi 2 parser, see if I can fix this for you. Maybe let's start with the Jedi 2 parser. Just assemble this for you. A few things I need to fix here anyway. So Jedi 2 parsers, you're going to need to, so this is what I gave you. Okay, but then what you're going to need to do is have a freeze parser. It's a little bit bigger for you. Freeze parser is going to be the word freeze followed by left paren followed by an expression. Let me just think about just for a second. Yeah, has to be this way. Okay, and then in here, you're going to, this is going to make thunk. And then you're also going to have a delay parser. Exactly like this. So the word delay in it. This makes a text. Then here, we're going to override the term parser. This bit in it. So this is 2.1. You're going to have to add the freeze, the word freeze, the freeze bar. Now, the reason I hesitated for a moment is I thought, well, gosh, these are just function calls. Why can't I just put freeze and delay in the ALU? I'll let fun call handle it. But you can't because fun call is going to execute these expressions. We don't want to execute the expressions. We want to, put them on ice. Okay. And now Jedi 3 parsers then go back and grab that. And so what we're adding here is it should extend this, shouldn't it? Lambda freeze delay fun call lock assignment and dereference we want. Oh, let me copy it. Annoying. Now, what is it, like secret information or something? That's if I did it. This. So here's Jedi 3 parsers extends Jedi 2 parsers. And so now, yes, the override's going to have freeze and delay in there. And what I will do, and I'm going to start taking notes here. I will update the Jedi 3 parser updates and ALU updates. I'll get that done. Okay. So I will get that out there. It's important that we call freeze and delay before fun call Otherwise, because the syntax here looks like fun call syntax, but it's not. They have to be treated specially because we don't want this expression to get executed. Okay. Does everybody understand what has to happen? These classes, you have to create these classes, very easy. Start with that maybe. Oh no, you have to start with the variable class. Forget about the store class. We'll start with the variable class. and then iteration class, assignment class, update the ALU with the dereferencing and var like I've done here. And yeah, and we're skipping store and then do the parsers and, and you should be set. Okay. So nothing in Jedi 3 depends on anything in Jedi 2.1. So they're kind of independent of each other. If you're completely lost about Jedi 2.1, just go on to Jedi 3. Any other questions? Yeah, assignment. And so Samij is asking, assignment will only deal with variables, correct? As in check if VBL is a variable. That's correct. So that's going to happen in the no, you're right. It happens in execute, assignment, execute. And this should, by the way, happen like in almost all of your special forms. Special forms are not handled by the ALU, which means that they're not going to enjoy any of the type checking done in the ALU. And so you have to do all of your type checking in the execute methods. So execute for a variable. See, a variable is going to, what does the variable have? No, assignment. What does the assignment has? It has an identifier, so count, and an expression. And so what it's going to do is it's going to execute the identifier. VBL will execute the identifier. That's going to return a value. And then it'll say a value is not an instance of variable, throw an exception, a type exception. There's obviously been some type error or something. Then you execute update, and then you set the variable's content to the value of update. Iteration here, here's a little challenge for you. It's not a big challenge, but execute an iteration, try to use while in there. Okay, so first of all, the condition has got to be a Boolean. When you execute the condition, it has to be a Boolean, a bool. Okay, and execute is being implemented here in Scala. So what I'd like it to be nice is if what you're saying in execute per iteration is that while in Jedi translates more or less into a while in Scala. Yeah, type errors for iteration she's asking about. Yeah, this condition has got to, when you execute the condition, it better return a bool for a value. If it doesn't, then you should throw an exception. Also, the value returned by iteration.execute and assignment.execute is done, is notification.done. Okay? And the reason for that is both of them produce side effects. Assignment updates a variable, and iteration also updates variables, right? Count and whatever else you have there. And so since they create these side effects, our policy is that the return value is something useless, a notification. Well, I'm having an office hour tomorrow at 10:30. Get that scheduled. So if you're stuck on any of this, there's an office hour on Monday as well, with plenty of opportunity to ask about it. So we don't have time to complete the implementation of Jedi 4 and 5, but you are responsible to understand how they work. And although we're not going to do them as an assignment. So I'm just going to give you a quick overview of Jedi 4.0 and the basic idea of it. And then on Tuesday, we'll do Jedi 5.0. Will I be posting 4.05? I will be posting the information you need to know about 4.0 and 5.0. Here's some of the, like the Jedi 5.0 implementation is quite involved. So Jedi 4.0 extends Jedi 3.0. What Jedi 4.0 brings to the table is object-oriented programming. So now, come a long way. Now Jedi is going to have objects in it. And the way that we're going to do objects is going to be kind of similar to what we see in sort of similar to what we see in Scala and JavaScript. Okay, and we're going to introduce some rather interesting another approach to object-oriented programming that some languages use. It's kind of interesting. So here's a little demo of it. So I'm defining account 1, and here's like a new piece of syntax, object. Okay, so the syntax here is the object, word object, followed by a block. Okay, so this is going to create an object, and this object is going to have in it, this is a bank account object. It's got a variable called bal. It's got a function and a function called deposit, which increments bal. We get an OK. And now I can do account1.bal, and I get, oh, it's a variable containing 100. And I can do account1.deposit 67. It says done. And now when I ask what account1.bal is, it's a variable containing 167. Right? So I've created account 1 is a bank account object. It has a field called bal, a member variable called bal, and it has a method called deposit, which modifies its member variable. Okay, everybody get the idea here? It's a singleton object, just like you would do maybe in Scala or JavaScript. Now, there are actually the world of object-oriented theory and programming, there are these competing schools of inheritance versus delegation. Scala, actually, you can do both in Scala, although I kind of sloughed over the delegation part. So inheritance, just think about this for a moment. What does inheritance mean? Well, you are inheriting the features of a superclass. And so, for example, somebody might call a method. You didn't declare the method. You don't have this method, but oh, good, you've inherited the method. So it still works. In delegation model, if an object receives a message that it doesn't understand, it has the option of passing that message off to another object. And that one can pass it off to another object and so forth and so on. So you get these chains of objects, and they're sometimes called delegation chains. This is more flexible than inheritance. So inheritance is kind of like delegation for classes, right? So if a method isn't in an object, in a class, you go to the class that it extends. If it's not there, go to the class it extends. But all of that happens at compile time, not at runtime. At runtime, we can create objects. We create these delegation chains. So that gives us a lot more flexibility in, in code reuse. So now I'm defining ACCT. This is an object, and it has just a single method in it, withdraw, which is making reference to BAL. Okay, even though there's nothing called BAL defined here, but then look, it extends account one. That means that anything in here that you don't understand, go see if account one understands it. So now account.bal, look, 167. Right? What happened? Well, I'm saying to account, tell me about the value of bal. And he's looking in here going, well, geez, I don't have anything called bal. But instead of freaking out, he passes the message on up to account one. This guy here who does have bal in him. Okay, here I'm going to withdraw $19. Now account one.bal is $148. Okay, but I could also deposit money in ACCT because that'll just get delegated to account one. I always think of delegation as something that they do like in the front office when a customer asks for something, right? They say, hey, sure, I can do that for you, but then they delegate it, to some tech guy in the back room who has to do all of the work, and then he gives it back to the front office guy who gives it to the customer, and then the front office guy gets all of the glory for it. So here, for example, I'm really impressed with this ACCT guy because he's not only has withdraw, but he also has balance and deposits. Whoever created ACCT must be some great genius, but really he's not so smart. He did define withdraw, so we have to give him credit for that. But here's the tech guy in the back room who's doing all of the work for deposit and bal. But meanwhile, ACCT gets all of the credit for it. Life is not fair. What about classes? Object-oriented programming, we should do classes. Well, here we're going to take the approach that's similar to what you see in Scala. Remember, in Scala, we conflate the idea of class and the constructor for the class. So here, what we're going to do is we're just going to identify classes straight out with constructors or function. For us, a constructor will be any object, any function that returns an object as its output. Okay, so I want to make lots of bank accounts. So here, I'm going to create a function. The input to the function is the initial balance, the initial amount that's going to go in there. And then here, the body is create an object with balance, which is a variable containing the initial amount, and then deposit and withdraw methods. Now look, so savings, make account 50, checking, make account 93, savings dot withdraw, checking dot deposit, right? I'm transferring money from savings to checking, right? You can see their balances. So you can use this make account. I sometimes call these factory methods. Factory method is any method that creates a new object and returns it. So we use factory methods we're thinking of factory methods as constructors, as classes. So we're mushing together all of those ideas in Jedi. JavaScript, same thing there. This is how you would do a class, in quotes, in air quotes, in JavaScript. It's just a factory method. Okay, so I hope you think that's cool. How is it done? Well, here's how it's done. If you think about it, a long time ago. Let's see. I have it here. Yeah, so a long time ago, you'll recall I gave you the definition of environment. Maybe has an extension. It extends hash map. And then you may not have even noticed it. It said with value. Okay, and I said, oh, I'll talk about that later on. Okay, well, now it's later on. So with value means that even though environments live in the, an environment lives in the context package, it is a value. Okay, and we haven't used that fact at all until now. So environments are values. Why do I need that? Well, back to here, and I defined account one. Okay, so I have like this special kind of syntax object, and when you execute this object expression here, it creates an environment. In other words, objects are environments. And this is creating an environment that contains the binding for val and the binding for deposit. And since it's being bound to account one, this environment created by executing this block, so you just execute the block normally, but what you do is you return not the value of the last expression of the block of the temporary environment, you return the temporary environment. The temporary environment is the value of executing a block, so an object here. So the syntax is the word object followed by block. You execute the block, but it returns the temporary environment. It's not really temporary because it's being given a name in the global environment. And now when you do account one.balance, so this is adjust the parser for this. All you do is you just search the environment named by account one, you search it for the identifier val. Same thing here. Account one.deposit, you search the environment named by account one for a function named deposit. You call that function. What about this here? Well, remember, account one is the name of an environment now. An object and environment are the same thing. And so here I'm creating a new environment, but it's going to extend account one. Remember, environments can extend each other. Let's go back here. So the environment I'm creating is ACCT, and its extension is ACCT1, which automatically, the way that apply works, it automatically goes and searches that environment. Okay, so it's really easy to implement this style of object-oriented programming, because you've already got it with environment. Environments are already of values. They can already extend other environments. They automatically search through the entire chain of environments, looking for whatever it is you're looking for. Okay. The only thing that's tricky is this dot syntax. This is sometimes called a qualified name. And so that requires some tricky parser stuff, but that's not the part I want you to understand. What I want you to understand is the semantics part of it, the part of it where, how we're going to use representing objects as environments. And while I'm at it, I'll throw in there, I might have, let me just see if I have a link to this here. Take a quick look at this. It is also possible to represent objects as functions, right? So here, this is how, so one of the reasons why people were nervous about mixing object-oriented programming with functional programming, which is what Scala does, is that in functional programming, we have a different approach to representing objects. And people were afraid that, well, somebody might try this in Scala, come up with a different idea for objects. And so I'm demonstrating how that's done here. Bad of me, but so here I'm going to show you how to make bank account objects in Scala without using their idea of object. So make account, okay, is a function, okay, and in this function, remember how you execute a function same way in Scala as in Jedi. You're going to create a temporary environment and execute the body in the temporary environment. And in this temporary environment, I'm going to define balance, deposit, withdraw, all of the usual bank account functions. And then I'm going to define a function called dispatcher, which takes a command as its input and an amount. Right? And if the command is deposit, it calls deposit. If it's withdraw, it calls withdraw, and so forth. It's called the dispatcher method, similar to execute for the ALU. And then here's the kicker. I return the dispatcher, okay? Which means the dispatcher was defined, it's a closure, right? And it was defined in an environment where all of this stuff was in the environment. Okay, so that environment doesn't go away. It's the closure environment. It's the closure of dispatcher. And so then I can do stuff like define savings as make account, checking as make account, and then I can deposit $30 in savings. I can withdraw $30 from checking, and then I can print this out. So you can actually run this program, and it gives you the expected results. So the way I think about it, grab my paper, my pad again, and then I'll let you go. A little excruciating to sit in front of your computer all day. Believe me, I know. Here's the way I think about it. You have a dispatcher closure. So here is the way I think about it. So an alternative way of representing objects is as a closure. And the closure here is your dispatcher function. Its parameter is the command and the amount. Okay, its body is the match expression. And its defining environment is this temporary environment created by the call to make account. So this will be different each time you call make account. Make account returns a function. I mean, this is what functional programmers like to do. They like to write functions that return other functions. So what I think about it is I think of an object as like a lovely little garden, you know, lovely little things in it. And I think about the dispatcher as like a vicious guard dog who guards the gates to this garden. So if you'd like to sample some of the stuff in this garden, you have to go through this guard dog. You have to call him and give him your inputs. He's going to go into the garden and pick whatever flowers you need to have picked. Maybe he'll ask you for your credit card number, your password, or maybe he'll just bite you. And you know, and so that in functional programming is what an object looks like. It's a closure sitting in front of a private temporary environment. So in a sense, this is yet we're doing the same thing. We're representing objects as environments. It's just that we're doing it functional style here, whereas what we were doing in Jedi 4.0 is just, you know, kind of a more traditional, straight up, okay, it's an environment. An environment is a value. When you create an object, you're just creating a private, secret environment. Okay, that's all I have for today. I will schedule an office hour for tomorrow. I'll get that out to you. If there are questions, let's see, so I'm being asked here, CS Club on campus is currently having its elections for officers. I thought that those got canceled, Sumija. Didn't the chair cancel the elections for the CS Club, or is that a controversial matter? Anyway, maybe she's just finding out about this, and you want to post on Canvas about it. Still going to be until May 3rd. I guess you can put something, yeah, you could put something on Canvas about it. You know how to do it. Do I have to do anything other than say okay? No, apparently not. Okay. I will see you in office hour tomorrow. And if not, I'll see you in office hour Monday. And if not, I'll see you in class on Tuesday.